Hi, welcome. Today we'll talk about matrix multiplication. Okay, you might have already touched a little bit on this in the past, but today we'll be talking about scalars and scalar multiplication plus actual matrix multiplication. Okay, all right, so this right here is a bad boy. This is an example of a scalar. It's just a number. Okay, now scalar multiplication works like this. It works a lot like distribution. So you are going to be multiplying each one of these terms inside of the matrix by 5. Okay, and so your answer is going to look a lot like this. Okay, it's going to be 60, 45, negative 15, 20, 40, negative 35. So it's literally you're just multiplying that. Now, matrix multiplication is going to be a little bit more interesting. All right, so we need to talk about some stuff, and we've already talked about sizes and everything, and I know you guys know how to work with that, but I want to talk specifically about the size. All right, so let's say that this is 5A. Let's call this matrix 5A, and this was matrix A. Whenever you write a new matrix, you want to make sure you represent the operation that was done to it before. Okay, now matrix A is going to have rows go across and columns go up and down. So matrix A is going to be a 2 by, and we're going to have 3 columns. So 1, 2, 3. So matrix 5A and A are actually a 2 by 3 type of matrix. So that stuff is pretty simple, straightforward for that. Okay. Some properties of scalar multiplication we do need to look at in a sec, so I'm going to talk to you about that. Okay, so far we've only talked about multiplying a scalar in a matrix, which is scalar is just a number and a matrix is actually a series of numbers. Now what if we multiply two matrices? What if we multiplied two matrices? Okay, now if we multiply two matrices, we would need to pay attention to the rows and columns. So let's say, let's just give an example. Let's say the matrix A, we're going to times that by matrix B. Okay, now let's say that matrix A was a 2 by 3 matrix. Alright, now whatever B has to be, it has to be 3 by something. The reason being is that the rule in this type of working with math is the first matrix columns need to equal the second matrices rows. That's the word I was looking for. Alright, let's just bring that, let's make it a 3 by 2. Okay, so what that means is that I can now multiply these two. Now what type of answer is A times B going to be? So that means, okay, what is this going to be? Alright, well it's going to be AB. Okay, pretty simple, straightforward. Now that matrix is actually going to be a 2 by 2 matrix, because what you're going to do is when you end up multiplying everything, your answer will be the leftover stuff that you did not use, which was the 2 rows in the first one and the 2 columns in the second one. Now you're not literally putting those 2 rows, this is just going to give you the dimensions. Okay, so like for example, if I had said that this was a 4 by 6 and this second matrix that we're multiplying by was a 6 by 2, our answer matrix size would be a 4 by 2. Okay, something as simple as that. Now, could we multiply something that has a different, well, yes, obviously we need a different size, and square matrices are really easy. But what if we had something like this, a 3 by 1 by 3 by 1? Okay, we cannot do this. This will not multiply because these two do not match. All right, and you'll understand why in a sec. Exactly why, but for right now, the first columns do not match the second set of rows. Okay, all right, so let's actually see how this works. All right, so what we're going to do is multiply these two right here. And so what I'm going to do first is I'm going to show you the answer of A times B, just to show you the difference. Okay, so this is actually a 2 by 3 matrix, and this is a 3 by 2 matrix. So our answer for A times B is actually going to be a 2 by 2. Okay, so what you do first is you draw out the actual size of the matrix. So 2 by 2 is just going to be our simple square. One right here. Okay. All right. So what I'm going to do is focus on the first row. And what I'm going to do is I'm going to multiply it by the first column and add all the terms. So I'm going to take the 3 times the 5, get 15. 1 times negative 3 is negative 3. And 0 times 4 is 0. So that would be 15 plus negative 3. That would actually be 12. So that's my first term. Okay? And then what I'm going to do is I'm going to move my focus from, I'm going to keep it over here on the first. I'm going to move it over to the second. And now what I'm going to do is do the same thing. So 3 times 10 is 30. 1 times negative 1 is negative 1. And 0 times 9 is 0. So 30 plus negative 1 is 29. Okay? And now what I'm going to do is I'm going to switch my focus back to this first column, but I'm going to switch down to the second row here. Okay? All right, so 4 times 5 is 20. 2 times 3, negative 3 is negative 6, so 20 plus negative 6 is 14. And negative 6 times 4 is negative 24, and that should give me a negative 10. Okay, and then what I'm going to do is I'm going to shift my focus from here to here. All right, 4 times 10 is 40. 2 times negative 1 is negative 2, so this is 38. And negative 6 times 9 is negative 54. So, negative 28 minus 54 is going to be negative 26. There we go. And voila, I actually have my answer all set up. Now, if I wanted to reverse this and have a B times A type situation, I could do the same exact thing, okay? Except my answer would not be a simple 2 by 2 matrix. Now if you notice, I'm switching the instead of it being this way where it was a 2 by 3 times a 3 by 2, now it's a 3 by 2 times a 2 by 3, so my answer should definitely be a 3 by 3. Okay, so now I'm going to focus on this first row and then this first column and just work my way across. So 5 times 3 is 15 plus 10 times that, so that should be 55. Okay, and then I move my focus over here to the 1 and 2. 5 times 1 is 5 plus 20, that's 25. So 25 is in my next term. Alright, and then once again I move my focus over here. Okay, and 0 times 5 is 0, and that should be negative 60, because obviously negative 6 times that. And I just work my way down and I'll fill in the rest. Oh, and then, I'm sorry, I'm not going to pause and let you guys see that. I'm going to focus on the second row, and then I just work my way across. Okay, and voila, I have everything all multiplied out so that I'm filling out negative 10, negative 7, 6, 48, 22, and negative 54. Okay, now this is the longhand way, and I want to show you the shorthand way, which is using a matrix calculator. Alright, so I'm at metacalculator.com, and this is the matrix calculator version. So what I'm going to do is I'm going to put in my matrices, so I'm going to make the size, so let's make this a 2 by 3. Make this a 3 by 2. There we go. Okay, we're going to come up with different numbers. 14, 7, 5, negative 1, negative 3, 8, and then 10, 1, 1, 5, negative 6, negative 8. Okay. Now I can spend all day here and just work with this, but I'm going to go ahead and show you the operations are down here. So I can try to multiply these two. If you notice, this is a 2 by 3 and this is a 3 by 2. So matrix A times B is the first one. And I should get a 2 by 2 matrix. Voila. Pretty simple and fast. Now if I go to the reverse, it's going to be a 3 by 2 and a 2 by 3. So I should be getting a 3 by 3. Voila. It's as simple as that. Now if I wanted to multiply them together, that does not work. And what you're going to get is this little message up here. Columns A must be equal rows B to multiply. Okay? So in other words, the first and the last. Alright, so we definitely cannot do that. Now the only time you can use these buttons right here is if you actually have a square matrix, and then you can actually multiply them together and just work with that, okay? Alright, later on we'll learn all these buttons, but here's another cool thing. You can actually do the addition, and you need the same size to do addition or subtraction, and just work that way, okay? Alright, but the cool thing is that now you know how matrix multiplication works. You know why the rows, the first set of columns must match the second set of rows, okay? And now you know a calculator that will actually help you calculate this stuff really fast. Alright, that's it for working with matrix multiplication. I will talk to you guys later. Bye.